this morning. Okay, good morning, guys. Welcome to our first day of MAC 1140. I just got my first look at myself today and realized my hair is all over the damn place. Sorry about that. But yeah, welcome to our first day of pre-calculus. This is generally how class is going to look. We will be meeting at 8 a.m. in Zoom Monday, Wednesday. We're going to do the normal sort of first day stuff, syllabus stuff. I'll walk you guys through kind of the basics of how the class is going to work. I'll show you where things are and what you'll be expected to do. And then we are going to start on a little bit of mathematics today. There's going to be a homework set that opens up for you a little later in the day. And we'll talk about when that first homework set is going to be due and what sort of patterns we'll be following for the remainder of the term. Okay, so let's do it like this. I'll fire up QCam. We'll get a copy of your syllabus here. We'll pull that up together that way you can see. I do appreciate a number of you having your cameras on. I think that's really nice. It's good for us to sort of get to know each other on these first few days, especially. I'm happy to see your faces and to get a feel for who is here. I'm going to go ahead and share my screen now. If you could, please, I know that automatically maximizes and that can get in the way of other things, but hopefully you're not doing anything else. And I'll ask that you do generally allow it to stay maximized, because this is where you will be seeing the notes for the class. Get that to focus. Oh. So this is my schedule. You don't need that. All right. That's lighting. Let's see what we can do better. Kind of reflective. There we go. Okay, so this is MAC 1140. It's section OR1. That's a pre-calculus class. And today is 8/23/2021. So every day I'll kind of begin class like this. We'll talk a little bit about what it is we're going to do today. So today we're going to do the normal first day stuff. Which includes things like the syllabus, Canvas, showing you Canvas, and WebAssign. We'll talk about class policies. And then we're also going to start chapter 1, which is all sort of preliminary material. So chapter 1 in our textbook, and I'll show you what the textbook is in a second, is actually not a part of Santa Fe's official material for this course, but I've found over the years of teaching pre-calculus here at Santa Fe that it's worthwhile to spend a little bit of time on those things that we're supposed to assume you remember from high school or college algebra or wherever. We're going to move through it very, very quickly. I won't be going over all the material from college algebra, not even close. But I will just kind of, you're going to have one homework set and we're going to have 1 or 2 lectures where we spend some time just sort of covering ground that I need to make sure you have solid, and not just that, but fresh in your memory, so that you don't get hung up on things in the first few parts of the course that are really essential. We're going to start here, of course, and the syllabus. I know it's not anybody's favorite thing to do, but we got to do it. So in case you haven't already done so, here's where you find the syllabus. You come over to Canvas, navigate to our course. You guys should have all been loaded into this course on Saturday. When you load Canvas, you'll see this, and this page is called the syllabus page in Canvas, but it isn't the full syllabus. It's sort of just the absolute bare bones basics, the stuff that you really, really, really need. So of course, my name is John File Sticker. You can call me JP or John or whatever you're comfortable with. Class meetings. Oh, I've got this Monday, Wednesday, Friday, right? We don't actually meet on Fridays. So first, let me apologize for that. That's not correct. Office hours are going to be Monday, Wednesday, Friday from 1 to 2 p.m. I may add one more office hour here. I'm not sure, like a Tuesday, Thursday office hour or something like that, but I have to talk to people from different classes and figure out what folks need. Something I would like you to do right now is get out your cell phone. Get out your cell phone, open the calendar app or whatever it is that you use to keep track of your engagements, and put the final exam in there. Do it right now. Because this is not a day that we would normally have class. It's after classes end. It's very easy to make a little error there. 12/6, December 6th, 2021, and it is at 8 a.m. It's a 2-hour final. It's longer than our normal class. So please go ahead and mark that in your calendar now. I gotta steal something from my dog. Maxie. Okay, a few other things I want to show you on this page before we move into the full syllabus. Tutoring. So Santa Fe has tutoring available through the Learning Commons. Many of the tutors are very good. I can specifically recommend Alejandro. He's excellent. If you follow this link, and scroll down, if you're looking for online tutoring, right, rather than in person, follow that link, scroll down to math and statistics. They've got the hours here. Let's see, go to the Learning Commons Canvas page, then math, science, business tutoring. And you'll see here for each sort of different subject, there are separate waiting rooms. So if you wanted help with our class, you're stuck on a homework problem or something's bothering you, it's not an office hour, you can't come see me, you don't want to wait for a response through email, just follow that sequence of links and then click here. And it will dump you into a waiting room. They'll ask you what class you need help with, and then they'll pair you up with a tutor. The specific hours for each class, let's see, are they listed here still? Specific hours, nah. But just follow that link. Click this guy, you'll be put into a waiting room, tell them what you're looking for help with, and they'll match you up with a tutor who can help you. Very much worth your time. What else is here? The little blurb down here is something I'd like you to consider. I really am on your side. I'm going to go through a few different places where there are some things I can do to help you if you're feeling like you're getting into trouble. But the big trick in this class is to stay on top of it, right? Do not let things go by. So you want to be doing homework every single day. And I know a lot of people say that. I'm not exaggerating. I really do think the easiest way to get through this class, the best way to get through this class without feeling stressed, without having a bad time, making sure you learn everything and making sure it feels easy the whole time, is to just spend an hour, right around that hour or two every day on the homework. So spend at least a little bit of time every single day working on some math problems, and it will make your life easier. If you fall behind on the homework, it's very, very hard to make it through the class, because not only will you be behind on those assignments aren't worth a whole lot, but you'll also be having a hard time following the lectures, because practicing the homework is where you get the skills you need to understand the next lecture. So my advice, a little bit of time every day. Not a whole lot of time, just an hour or so, but a little bit of time every single day. I'm going to go ahead and open up the full syllabus. So if you click this link right here, you'll download a copy of the syllabus. Well, we'll save another copy, or I'll just open up some. Save a copy somewhere on your computer, because you'll want to refer back to this a few times throughout the term. All right. So we've already gone over the basics. My name is John Filesticker. I'm an assistant professor here at Santa Fe. I've been here for about 5 years now. My office on campus is A031D, although I do not spend much time there in the physical office because I'm still working remotely due to the pandemic. This phone number is my office phone number, but I have it set up to forward to my home right now. So if you call this number, you will be able to get a hold of me. But caller ID doesn't work, and voicemail doesn't work because it's all forwarded. So by far the best way to get a hold of me is either a Canvas message or email. Emailing me, if you're going to email me directly instead of using a Canvas message, I'll ask that you put the class in the subject line, like MAC1140.0R1, Make sure you include the section there so I know which class you're from, because I have several of these. I check my email like 5 times a day. I'll get back to you real quick, I promise. Class meetings, you already know this, Monday, Wednesday at 8 a.m. Office hours, Monday, Wednesday, Friday, 1 to 2 p.m. The place you go to join the office hour, right here. If you click this link, it'll join a Zoom waiting room, and I'll pull you in one at a time because sometimes people need to talk privately. But go there between 1 and 2 p.m. on any Monday, Wednesday, Friday, and I will get to you eventually. The final exam, again, make sure this is in your phone. Do not let today go by without this being in your calendar, 12/6 at 8 a.m. The prereqs, got to get a C or better in college algebra or equivalent. The text is Stewart's Pre-Calculus. Physical copy is here. Show you on the dot cam. It looks like this. It's a fine textbook. You do not need to buy a hard copy of the text, however. You're welcome to if you would like to have a hard copy. I think having a hard copy is nice in some ways, but you're not required to. There is access available to an electronic copy through WebAssign. One thing that you are required to buy for this class is a WebAssign access code. You absolutely need one of these because the homework and the quizzes are online for this class. The exams are also online, but we're going to talk about that. They're not on WebAssign. But the homework and quizzes are in WebAssign, and that's a significant portion of the grade together. You can get this access code directly from Cengage. You can also get it at the bookstore. You can use financial aid to get it at the bookstore. And you can sign up for the class in WebAssign even if you don't have your access code yet. So one of the very first things I'm going to ask everybody in this class to do is make sure that you get signed into WebAssign today. Get into WebAssign, get into our class today. The class key, the unique identifier you need to get into our class in WebAssign is SF College 74214315. So you're going to want to copy this or keep a copy of the syllabus on your computer so you can register for our class in WebAssign. As you go through that registration process, there will be a step where they ask you for your access code. The access code is not this. This is the class key. The access code is your proof of purchase. It's how you prove to them that you've paid for the class. If you don't have your access code yet, what you need to do is just scroll down to the bottom of that page where there's a little gray link that says begin with temporary access or use trial access. That will get you through the first couple weeks of class. But you do still need to buy an access code. Everybody needs an access code. Okay. To get to WebAssign, you can follow this link here. It will take you here. And then you can go to enter class key and it'll walk you through the steps to sign up for our class. Again, if you don't, so enter the class key. Then when it asks you for the access code, if you don't have your access code, just scroll down on the page and look for a link that says start trial access or use temporary access. That will get you in and you need to get it in today. There's homework opening today. Oh, this dog. Puppy. Sorry about that. I'll be populating Canvas with some assignments. I can show you guys what this is going to look like. I'll get those in there a little later today, just for reference. Here's the class I taught over the summer. So there will be an assignment for homework, an assignment for quizzes, and then an assignment for each of the exams. Sometimes I do makeup tests if these are necessary, and there's a separate assignment for each test where you submit your written work. Once all of those assignments are in, which again, they will be in later today, you'll be able to go into the grade book and enter these little what if scores to try and calculate your grade. So you can calculate your grade at any time in the semester. You should always know your grade in the class. Okay. More syllabus stuff, calculators. If you want a calculator, I understand you don't need a calculator for this class. There's no place in this class where you will be required to have a calculator. But if you want one, I know a lot of people feel more comfortable with one. The TI-32XS is the only one that's allowed. Definitely no graphing calculators, no TI Inspire, nothing capable of symbolic manipulation or anything like that. So the only kosher calculator, especially when it comes to tests, is this guy. If you're someone who you feel more comfy with a calculator in your hand, you feel insecure, uncomfortable without one, don't feel bad. I get it. I was like that in college. This is the one you need. So don't wait till the day of the test and be like, oh shit, I don't have that calculator. If you know you're going to want a calculator, make sure you grab one of these. They're about $10 at Walmart. Other things you're going to need, you need a computer with an up-to-date web browser, consistent internet access, webcams. Those are all necessary. Another thing you're going to need is a cell phone that's capable of using Zoom. So you need a smartphone. I'll explain exactly why that is when we talk about exam proctoring. But basically, to proctor the exams, we're using a combination of things. We're going to use HonorLock, and we're going to use Zoom on your smartphone. So you'll need to have both of those devices up and running on the day of the test. The alternative to that is to take the test in the testing centers, which is totally allowed, and then you get around all that stuff. Course description. This class is designed to get you ready for calculus. That's it. So this class, together with MAC1140, which is trigonometry, is supposed to make sure you have all the necessary algebra and trig background to knock out the main 3 calc classes, Calc 1, MAC 2311, Calc 2, MAC 2312, and Calc 3, MAC 2313. We're going to talk a lot about functions. We're going to go over each of these different categories of functions in quite a bit of detail. The emphasis is going to be on graphing. You will be doing a lot of function graphing. You'll be doing it by hand. You'll be learning how to graph functions by hand, which is hugely important for Calc 1. Best predictor of whether you'll succeed in Calc 1 is if you can tell me what the graph of the natural log function looks like. Can you tell me what the graph of x minus 1 quantity squared looks like? Those sort of basic things are really what you need to get through Calc 1. We're going to talk a little bit about conic sections, things like hyperbolas, parabolas, ellipses, and circles from a perspective of geometry rather than from the algebra perspective. We're going to talk about inequalities, specifically nonlinear inequalities, which are solved very differently than equations, not the way most people think of solving inequalities coming into the class. We're going to talk about systems of linear equations and how those relate to matrices. We're going to talk about matrix algebra and something called the determinant of a matrix. And then we're going to finish up the class by talking about these things called sequences and series. If you want to look at the full course objectives, you can follow this link. It takes you to the Santa Fe page for the class. Cell phone policy is not super relevant in the day of Zoom, but just don't distract other people with technology. This goes into the Discord server also, right? So I understand if you want to talk to each other. I love that you guys talk to each other. It's a good thing, but during class, let's not blow up the Discord server. Let's keep the chat here minimally distracting. That's the goal. I am going to take roll every day using the Zoom logs. So please, when you sign into Zoom, sign in using your real name or whatever name you have on your Santa Fe ID, because among other things, that's how I report you as having attended for financial aid purposes. Your financial aid will not disperse until I say, hey, you're coming to class. And in order to do that, I need to know that you came to class. And in order to do that, I need to know that I need to have your actual name here in Zoom. So please, when you sign into Zoom, use the same name that is on your Santa Fe ID. I will be taking roll every day, but there is not an attendance component to the grade. You don't lose points in the class for not showing up, but it will hurt you, right? Obviously, if you don't show up, then it's going to make the homework very hard. It's going to make the quizzes very hard. It's going to make the tests very hard. So I really, really encourage you to come to every single class meeting. Don't miss them. It's super important. Makeups, I'm pretty relaxed about this shit. If a homework assignment happens to go by and you are not satisfied with how much of it you got done or not satisfied with the grade you got on it, you can just let me know. There is a mechanism within WebAssign for you to request an extension. I pretty much always grant them. Very, very rarely do I deny an extension request. So if you need more time on a homework, just request an extension. I'll give it to you. If you miss a test, that's a little different. So if you miss a test, I need you to reach out to me, ideally ahead of time, directly through a Canvas message or an email. Let me know what's going on and I will work with you. But we have to get that makeup scheduled real quick. My rule is within 1 week. So if you miss a test and you contact me 6 days after missing that test and say, oh, I was sick, can I take the test? I'm going to say yes, but it has to be today. And if you reach out on day 7 or day 8, then there's nothing I can do. Homework and quizzes. Like I said, there's going to be homework in WebAssign, 2 homework sets each week. And I think, yeah, Monday and Wednesdays are the policy that I had previously. I'll probably stick to that. I may change that, but we're going to have 2 homework sets each week, and they'll be coming due regularly. So you want to stay on top of that. The idea is the homework set that's due on Monday is the material that you need for that Monday's lecture. So if you haven't mastered that homework, you're not really going to understand what's going on in class on Monday, and the same deal on Wednesdays. So the homework set that I'm going to open up for you today would normally be due on Wednesday at the start of class. I probably won't do that this week because I know it's going to take some time for people to get in here. People are still registering and dropping from classes. But generally 2 homework sets a week, 1 due at the start of class each day. There's going to be about 1 quiz per week, and those will be due on Mondays. Watch the due dates in WebAssign, right? Definitely, again, I'm very lax with extensions. I'm happy to grant extensions, but you really don't want to fall behind. This class has a lot of material. Midterm exams, oof, I need to update this too. 4 midterms, 4 midterms, not 3, and 1 final. So I'll update this. 4 midterms and 1 final. I did update the grade stuff down there, so we'll take a look at that a little later. The final exam, again, December 6th, 8 a.m. I do record all of our Zoom meetings. I do post the Zoom meetings, the lectures to YouTube. So if your camera's on, you will appear in those. Just be aware of that. Make sure that you're dressed, stuff like that. Important dates. So obviously classes start today. The last day to add a class is 2 days from today, the 25th. The last day to drop, get your money back, and have it be like nothing happened is the 27th. So I would mark this on your calendar also. If you decide you really don't like the format of the class, you really don't like the amount of homework, you really just don't like me, whatever, no harm done. Make sure you know whether you want to commit to this class financially by the 27th. Labor Day is the 6th of next month. We are closed for homecoming, US homecoming on the 1st of October. The last day to get a W in this class, this is another one I would put on your calendar, is November 2nd. If you stay registered in this class beyond November 2nd, you are getting an A through F letter grade. So the last day, if you decide things are not going well, I want out, I don't think I'm going to get the grade I need, you need to withdraw from the class by November 2nd. Withdrawing beyond that day requires the petitions process. So the Santa Fe does have a system for you to withdraw from classes beyond that date, but you have to file a petition. It takes a while. Usually you need a letter of support. It's kind of complicated. So you want to take a good hard look at your grade and make sure you are comfy with where you are by November 2nd. If not, then that's the time to drop. As that gets closer, I'll remind you, and I'll talk a little bit about how to decide if you're going to stay in the class or not. 11/11 is Veterans Day. The 25th and 26th were closed for Thanksgiving. Last day of class is December 1st. Final exam is again 12/6. You see this is all over the place in the syllabus. Please don't forget this. And then your final grades will be posted to East Santa Fe no later than December 14th. All right, here's the thing everybody wants to know. The homework, 45 points, about 7% of the grade. The labs and quizzes, right now we're not really doing labs because again, we're remote, but I'll have some things that are kind of like labs, but it'll all fall under this category, labs and quizzes. 75 points are about 11%. The midterms, there's 4 of them, not 3 as it said earlier, I need to fix that. 4 midterms altogether, 4 regular midterm tests are worth 100 points each, about 60% of the grade altogether. And then the final is worth 150 points each, 1.5 times as much as one of the midterms, and that's worth almost a quarter of the grade, 22%. The breakdown is here. It's the normal one, 90 to 100 is an A, 80 to 89 is a B, and so on, with the top 3 points in each designation earning the plus. The next page is all boilerplate syllabus stuff. Jellos, these aren't something you need to worry about. General education learning outcomes. This is just a tool that we use to see whether we're doing what we should do. If you guys are getting the things you need to get out of the class, it has no effect on your grade, doesn't show up in your transcript, but I got to tell you that there is some stuff in here that I'll be using to evaluate general learning outcomes. Not something you need to worry about. Academic integrity, this is something you need to worry about. And we're going to talk about this a little bit more. I would really like you guys to all read this. I know it's a long document. Right, obviously not a fun read, but I would take a look at this. You can skip over some parts, obviously. Philosophy and overview are not hugely important to you. Definitions, these are all things that you guys would know because they're super intuitive, but you need to know the rules that you're being held to in this class. And I'll talk more about that in just a little bit. ADA, this is pretty straightforward. If you're registered with the DRC or you think you may be entitled to some testing accommodations or anything like that, regardless of whether you're registered with the DRC, reach out to me. Let me know. Let me know if you have some sort of disability or if you think you may qualify for any sort of testing accommodations, regardless of those facts. Whether you're registered with the DRC or not, talk to me and I will do everything I can to help you. If you need a note taker or you need extra time on tests or a quieter environment or anything like that, we want to make sure that you are accommodated as much as possible. Accessibility stuff. So all the materials that I publish for this class will be published as PDFs in LaTeX, which is a markup language specifically for writing mathematics. It's read well by screen readers. As far as I know, everything that we do in this class is ADA compliant, but if there is anything that you need or are having a hard time reading, watching, hearing, whatever, whether it's in the lectures or the homework or some of the Canvas material, just let me know. I can find a version of it that works well for you. Discrimination, harassment, this is one of those really obvious intuitive things. Just don't be an asshole. Be nice to your fellow students, be kind to me, be kind to any staff at Santa Fe. Show everybody the respect they deserve. Student rights and responsibilities is another thing you probably want to have a look at, especially since this is changing. There was a piece of legislation passed last year called HB 233. I just see Joyce correcting the day of the week there. Sorry about that. Thank you, Joyce. HB 233 gives you permission to record a lot of things, where previously you needed to ask permission to record certain things. These days, you can record more than you used to be able to without necessarily asking for my permission, but it is a subtle thing. There are some rules about recording your fellow classmates and exactly what constitutes a lecture that is allowed to be recorded. You don't need to worry about that. Again, I record all the lectures and post them on YouTube, but check out student rights and responsibilities just to know, again, sort of what you're being held to. The thing I really want to focus on this page is down here. So I've been teaching online for almost 2 years now. It'll be 2 years in the spring. And I have seen every form of cheating imaginable. I'm sad to say that within the last 2 years, I've been teaching overall for about 15 years at the college level. I've taught at different universities. I've taught at UF, teaching here for five and a half years, something like that. I've seen more cheating in the last year and a half than I had seen in my entire teaching career before then. And I know what it looks like, and I know what it sounds like. Not just the act of cheating itself, but I know what written work looks like when it's done honestly. I know what written work looks like when it's done dishonestly. Over the summer, I caught 6 people cheating in this class, MAC1140, on one test. And every single one of them were sent to Dan Rodkin's office, and they all had to deal with that really nasty, process through student affairs where you've got this like conduct trial, and it's shitty and it's embarrassing and it sucks. And some of those were people that I was very fond of. I'm very sympathetic. But I don't have a choice because we need to keep the value of these degrees high, right? The reason going to college is worthwhile is because most people out there in the world still acknowledge that a college degree means you fucking learned something. If I let cheating slide, then the value of those degrees starts to go down as the rest of the world realizes, oh, you can get these degrees without learning something. So here's my deal for you. If you feel like you might even be tempted to cheat, like you're nervous, the test is coming up and you're starting to switch in that way of thinking from like studying to where can I tape a cheat sheet, or from studying to where can I keep my second phone, from studying to which one of these apps will give me the best looking answers. If you're starting to even get a whiff of that going on in your own brain, first, don't feel bad. Everybody gets that sometimes. You feel under pressure, you feel like you might be boned. The second you get that feeling, reach out. Please, please reach out. It doesn't mean anything bad. People do it all the time. I'll tell you, since I instituted this policy, I've had at least one person, every single test, every single class do it, and I'm always grateful. I will never, ever be upset, disappointed, anything negative if you reach out and tell me that you're in trouble on an upcoming test. But reach out ahead of time, and I'll do something for you, all right? either I'll meet with you if it's early enough, then we can schedule a few extra like one-on-one tutoring appointments, like extra office hours with me. If the test is very close when you start to get that feeling, then I can move the test for you a little bit, right? I mean, it's not the end of the world, especially if I'm going to have people being sick or something like that, missing the test anyway. Then I'll just put you into that group with a makeup test. It's not a big deal for me to give you a few extra days to prep. I will do everything I can to flex for you, right? Flex in the old-fashioned sense, meaning like get out of the way, help you bend. If I catch you cheating, I will set you on fire and hang you up from the tallest pole. Please, please, please fucking don't do that. I hate it. You hate it. Nobody wants to be caught cheating. And I promise you, I'm very good at catching cheaters. Photomath, Symbolab, Mathway, Wolfram, all of it, right? I know what the output looks like. I run every single one of my own tests through all of those things. Please, 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 please don't cheat. I swear I will catch you. Instead of cheating, let me know that you're feeling like you're in trouble. I will work with you with extra office hours. I'll work with you at whatever time your work schedule requires. I'll move the test for you as much as I can. But please don't cheat. I swear I'll catch you. And that will be shitty for all of us. All right. Was that convincing enough? I hope that was convincing enough, right? I told you 6 people just last summer, right? 6 people, 1 test last summer. In fall of last year, my record is 9. Calc 2, exam 3, I failed 9 people in that class for cheating on 1 test. It happens every term, but please, 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 don't do it. Don't do it. Just reach out to me. I'll work with you. Okay, course calendar. So this is the last little bit of the syllabus. This is the stuff we're going to do and when we're going to do it. It's a rough outline. I want to warn you of that. So like, there's no guarantee that this exam will be on this week, but it'll probably be on this week. And I'll let you know as we're getting close. I'm going to do my best to stick to this, but sometimes things like holidays or hurricanes or, random bullshit happens that messes this up. In the first week, this week, we're going to talk about some chapter 1 stuff, preliminaries, things that you should remember from high school or hopefully have been exposed to in college algebra, but I know not everybody gets a quality high school education. I did not. Not everybody gets a good college algebra class. So we're going to go over some of that stuff quite quickly. Also this week, we're going to talk about functions and their graphs. So, this is all material that you should be familiar with, but we're going to look at it in a slightly deeper way, slightly different perspective. Moving on from there, the first kind of unit of the class is all about functions. So getting information from the graph of a function, average rates of change, transformations of graphs. And this is a huge section where you learn how to graph other functions by moving, shifting, dragging, stretching other functions' graphs around. We're going to talk about combining functions, what it means for a function to be one-to-one and have an inverse. And then we'll be ready for our first test. So our first test comes up through section 2.8, and it's all this sort of function basics. Then the middle part of the class, we're going to be looking at a bunch of particular classes of functions. So we're going to study quadratic functions as their own thing. That's going to go very quick. We're going to study polynomials in greater generality, degree 3, 4, 5, 6, 7 polynomials, bigger polynomials. We're going to learn how to divide them. We're going to learn how to calculate their roots. We're going to learn about the fundamental theorem of algebra and complex numbers. We're going to learn about rational functions, which are fractions that are made up of polynomial over polynomial. We're going to learn how to graph those things and eventually solve inequalities with those things. And then we'll be ready for exam 2. After that, we're going to move on to the next big family of functions, which are exponentials and logarithms. I'll introduce them. I'll teach you about the natural exponential function, Euler's number, base E. We're going to learn about logarithms, what they are. We're going to learn how to mess with them. Those are the laws of logarithms. And we're going to learn how to solve equations with both logs and exponentials. Then we will be ready for exam 3. After that, we're going to move into kind of the fun part of the class where we get to do all sorts of neat things that you've never seen before. Of course, you'll have seen systems of equations a little bit, probably since middle school, but we're going to look at them again from a much higher perspective. And then we're going to talk about matrices, which are really, really cool, totally new mathematical objects. We'll see how they relate to systems of linear equations. But then we're going to learn that they have an algebra of their own. You can add matrices, multiply matrices, all sorts of cool stuff. Turns out there's a sense in which you can divide matrices. Those are called matrix inverses. And then we're going to learn about a new function called the determinant and how it relates to this special thing for matrices called Cramer's rule. After that, we're going to learn about partial fractions, which is a way of taking big fractions, functions of big fractions of polynomials and splitting them up into much nicer things. And then we're going to talk about sequences and series, which lead to something called the binomial theorem, a nice way to expand without foiling large expressions. And then the last bit of the class, we're going to talk about conic sections from a geometric perspective. So parabolas, obviously you've encountered those before. It turns out there's a really nice way to think of those in terms of distance, as a collection of points that all satisfy some distance requirements. And the same is true for other important conics like ellipses and hyperbolas. And that's the class. So this is a week-by-week breakdown of what sections we'll be covering in each week. We're going to stick to it as much as we can, as long as we don't get messed with. I've done my best to modify this to fit around holidays and things like that, but it's hard to predict stuff like hurricanes. That's the syllabus. I bet you're all half asleep by now. Are there any questions on this? I did see that there were some corrections in here. 12/6 is apparently a Monday, not a Tuesday. Is that correct? Yeah, 12/6 is a Monday, not a Tuesday. So I'm sorry about that. Other things that were incorrect in here. We referenced 3 midterms here. That's not correct. There's 4 midterms. I changed those things this semester. So sorry about that. Okay. Coming back over to Canvas. Obviously, you'll find the link to every day's lecture here. I've posted a link to the Discord for the class. That's here, and I invite you guys to play around in this. This will be a great way for you to talk to each other, ask questions about homework. You can post pictures, and I will check this out at least once a day. Also, feel free to post memes or whatever the hell you want. I can give you a quick look at. There was a nice active one. This one was pretty funny. This is from my differential equations class over the summer. And people had fun with it. You can see it's fairly active. I guess there's no reason for me to focus on this for too long. But the more you talk to other people about mathematics, the better you will get at mathematics. It's like anything else. The skill comes from practice. And one of the most important things you can do is just build math into your everyday life. Make it a part of your regular vocabulary to talk about this stuff. You'd be amazed what it does for you. So I really invite you to follow that link from the announcements in here. Join the Discord, talk with other people.
Yes.
All righty. I'm trying to think, is there anything else that we need to go over here before we start on the mathematics? I don't think so. I think that's everything. Do you guys have any questions for me before we get started on the actual content of the course? Everybody feeling pretty good? We all have an idea of what's expected of you? I'm going to come back to the dot cam and we're going to start. Yeah, okay. All right. So in this class, we're going to talk about functions. That is our kind of main object of study. And functions are rules that map elements of one set to elements of another set. The elements that we'll usually be messing with are going to be numbers. So I'm going to introduce just some vocabulary. If you take the numbers 0, 1, 2, 3, and so on, and you put all of them into a box, we use curly braces for the concept of a box in mathematics. That is called the natural numbers. And there is some debate, believe it or not, kind of in a silly way. Some people consider 0 natural number and some people don't. So France includes 0. Germany does not. And in the United States, you'll find that there's a nice mixture of folks. Some people think that 0 is a natural number. Some people think that 0 is not a natural number. The natural numbers are the counting numbers, and I think it is certainly possible to have 0 things. So I definitely include 0 as a counting number or a natural number. But just be aware that when people refer to the natural numbers, they may be thinking of positive whole numbers, or they may be thinking of non-negative whole numbers. The positive whole numbers would just be 1, 2, 3, 4, and so on. The non-negative whole numbers would be 0, 1, 2, 3, 4, and so on. There is a special symbol to refer to this whole set at once. It is an N that is kind of bold with a second leg there. This is called a blackboard bold N. You'll see that notation from time to time. So if you see this symbol, that means we're talking about the set of all natural numbers, and those are just the whole numbers starting at 0. If you allow me to include negatives, so 0, which is neither positive nor negative, positive and negative 1, positive and negative 2, positive and negative 3, and so on, these are called the integers. So integers and natural numbers are not the same thing. Integers are allowed to be negative, natural numbers are not allowed to be negative. And the special symbol to refer to this whole set at once is a blackboard bold Z. The Z here stands for the German word Zahlen, which is how you say number in German. From here, there's a bunch of other number systems that we can talk about. One of the important ones is the set of all fractions of whole numbers. I'm going to tell you how to read this notation in just a minute. So this set right here, the way you read this is as the set containing, that's the curly brace, all things of the form m divided by n. This is this vertical bar here is read as such that m and n are integers. This set is called the set of rational numbers. Okay, and we use the word rational here, not as in like makes sense, but as in like is a ratio, right? Rational, ratio is just another word for fraction. These are all the fractions made up of whole numbers, right? So like 1/5, 2/7, -3/4. Those are all rational numbers. Any number whose decimal expansion terminates or repeats eventually is a rational number. That's a fun thing to try and prove. But when you're asked, is a number rational or not, we're asking, can it be written as a fraction of whole numbers, integers? The symbol for this, if I want to refer to this set all at once, is a blackboard bold Q. But since we're getting ready to work in calculus, the goal here is to get you guys ready to do calculus. You actually can't do calculus on any of these sets. If you just think of your inputs as being like whole numbers or integers, even rational numbers, that's not a dense enough collection in order to do calculus. Calculus is all about very, very little changes in input. And in order to talk about such minute changes in input, you need to include not only all the rational numbers, but all the irrational numbers together. That's called the real numbers. Now, the real numbers are a little bit harder to describe. So we will work primarily with the real numbers, which you can think of as all possible decimal numbers. And this is maybe the more convenient way to think of it, all possible distances between 2 points. Positive and positive or negative versions of those. The symbol we use for this is a Blackboard bold R. So the real numbers are kind of hard to understand because they include all of the natural numbers, all of the integers, all of the rationals, and irrational numbers. Which are things like the square root of 2, the square root of 3, or let's say the fourth root of 3. Why not? The fourth root of 3, pi, and e, all sorts of other stuff. Okay, so we're going to work primarily with the real numbers. And you can think of the real numbers as like all of these things together with the irrational numbers. And of course, they sit on a number line. Your first homework does have a few questions like, is this a natural number? Is this an integer? Is this a rational number? Is this an irrational number? And the thing you should think of for irrational numbers is that they are not rational numbers. So an irrational number is any real number that cannot be written as a fraction of whole numbers. So these are any real number which can't be written as a fraction of whole numbers. Right, what I mean by whole number here is an integer, right? The integers are the whole numbers. Okay. Another way to think of your rational numbers is as numbers whose decimal expansion goes on and on and on forever without ever repeating. That's a fine way to think of them. But I would like to get you thinking a little bit more like a mathematician. The fact that the decimal representation goes on and on and on forever without repeating is a consequence of the fact that they can't be written as ratios of whole numbers. All right, I'm going to turn the page here in just a second. Maybe I'll get some coffee while you guys write. Okay. All right, here we go. Remember, the lecture is recorded and posted to YouTube afterwards, so if you need to fill in some notes, if you miss something, it's not the end of the world. I am happy to go back if you miss something just small, but if you need to fill in a large gap or want to go back and polish your notes, make sure they're perfect, YouTube is the place to look after class. So the real numbers are what's called a complete ordered field. So we're talking about algebra from the perspective of a slightly more grown-up math class. This is how you would define the real numbers. You would say they are the unique, complete, ordered field. Complete means there's no gaps. In other words, between any x which is not equal to y, there are other real numbers. So no matter how close two real numbers are, this one is not the next one. There's between any two real numbers, no matter how close they are, there's another real number in between them. In fact, there's infinitely many. So other here is a bit of a stretch, or sorry, a bit of an understatement, infinitely many. Infinitely many other real numbers. So you take two real numbers on the line, and you look at that space that's in between them, right? Like the space between the real number 1 and the real number 2. In between those two, there's infinitely many other real numbers. Even between 1/3 and 1/4, there's infinitely many other real numbers. Even between 0.1 and 0.2, there's infinitely many other real numbers. So complete means no gaps. Ordered, this means you can put them on a line. Any two x and y, if x is not equal to y, are real numbers, then either x is bigger than y, or vice versa. So if you give me two real numbers and they're not the same real number, one of them is bigger. And a field, this just means given x and y, real numbers, we can form the sum, x plus y, the difference, x minus y, the product, x times y, and as long as y is not 0, we can form the quotient x over y, and they will all be real numbers. All right, so to an algebraist, a mathematician who studies algebraic structure, these are really important properties. These are things that we really care about. The fact that there's no gaps between any two real numbers. There's always more of them. The fact that they are ordered, they can be put on a line. One is always bigger than another if they're not the same number. And that they're a field, that you can do all this algebra stuff with them and you don't run into trouble. Now there's a small caveat, of course, we cannot divide by 0, right? When I say I can form the quotient x over y, that does require that the downstairs be non-zero, because of course you cannot divide any number by 0. You can divide 0 by anything. 0 over 5 is 0, that's fine. But 5 over 0, that's not defined. The reason for that, if you've ever been curious, why can't we divide by 0? The reason for that is because it would ruin multiplication. If 5 over 0 was equal to something, call it z, then 5 is equal to 0 times z. But 0 times z is supposed to always be 0, no matter what you get. So no matter what z is. So 5, of course, is not 0. Can't do that. It would wreck multiplication. All right, the number line itself. It's just a way of arranging the real numbers. They get bigger as you go this way. And they get smaller this way. So I would say that -10 is smaller than +5, right? Even though 10 is larger than 5, -10, it sits to the left of 5 on the number line. Okay, maybe 0 is here. 1 is over here. Something like 1/3 would be right here. Maybe pi is over here. All the real numbers sit on the line somewhere. The distance between any two real numbers. So I'm going to come in here and tag a couple special ones. Maybe I'll call this over here y, and I'll call this over here x. And that distance from x to y I'm defining the word distance here. Is the absolute value of x minus y. And remember what the absolute value function is. It's something that takes its input, and if it's positive, it leaves it alone. If it's negative, it makes it positive. The absolute value is an important thing when you're defining distance here, and I'll show you some examples. Let's find the distance. Between say, I'll give you a few things. X equals 5 and y equals 7. B, x equals -2 and y equals 3. C, x equals 1/3 and y equals -4. All right, for each of these, I'll go ahead and draw the number line really quick. It doesn't hurt to do that. So the distance between 5 and 7. I'll go ahead and draw my number line. I'll pop 5 here. 7 is, of course, bigger than 5. And just looking at the picture, without even thinking about it too much, I bet you could all tell me the distance here, right? What's the distance along this line from 5 to 7? You can hold the space bar to talk, by the way. Space bar in Zoom is like a walkie-talkie talk button.
2.
Yeah, it's 2, right? The distance between 5 and 7 is 2, right? In here, there's a 6, right there. So to go from here to here, that's distance from 5 to 6 is distance 1. 6 to 7 is another 1. So altogether, that's 2. But if we want to be careful about it, you can use this recipe. So the absolute value of x minus y, that's the absolute value of 5 minus 7, which is the absolute value of -2, which is 2. All right, let's move to the next one, from -2 to +3. Again, I'll draw my number line. I'll say -2 is over here, and +3 is over here. I thought I would put 0 somewhere around here. We don't really need 0 on the line to help us with this, but we can draw it. I want to find this distance. And again, looking at the line, you can probably figure it out, right? From -2 to 0, you got to hop over -1, so that's 1, 2. And then from 0 out to 3, you go over 1, you go over 2, so that's 1, 2, 3. 2 plus 3 is 5. But you can also use the recipe here. So the absolute value of x minus y, that's the absolute value of -2 minus 3. That's the absolute value of -5, which is +5. And then finally, to find the distance from 1/3 to -4, here we're going to have to do a little bit of fraction arithmetic. 1/3 is over here. It's a positive number. -4 is way over here. It's a 0 here again. If we want to write 0, 0 would be right around there. The distance between those guys follow the same recipe. This would be the absolute value of x minus y. That's the absolute value of 1/3 minus -4. Now, when you subtract a negative, right, we forget about the absolute values for a minute. We're just going to work inside, following your order of operations. Inside here, when you subtract this negative, that makes a plus. So this is the absolute value of 1/3 plus 4. How do I add those two? Silly question. I don't know. Someone help me out.
13 over 3 or 4 1/3.
That's correct. How do we get there?
You multiply 4 times 3 and then you add that to the top.
Very good. Yeah, in order to add or subtract fractions, I have to have the same denominator, right? This is 1/3 plus 4. Well, 4 is like 4/1. So to calculate my 1/3 plus 4, off to the side here, just real quick. I don't mean to demean you. I just want to make sure we've all seen this recently. I treat this as 1/3 plus 4 times 3/3. Now, in the second fraction, 4 times 3/3, this is like 4/1. So this is 1/3 plus 4 times 3, which is 12/3. And that's, now that the denominator is the same, you just add the numerators. So that's 13/3. And I would just leave it as 13/3. So this is the absolute value of 13/3, which is 13/3. And that's a good example of a rational number that is not an integer, right? 13/3 can be written as a fraction of whole numbers, but there is no way to write it as just one whole number. All right, so this is distance on the real line. I'm going to talk about distances a lot in this class. We're going to talk about them when we talk about graphs, like vertical distance, horizontal distance. It always means this. Any questions on what we mean here by distance? What's going on with the absolute values? What's going on with the fractions? Okay. I want to talk a little bit about rules for exponents. This is still just preliminary stuff. These are some useful tricks that people tend to forget. So if I take two numbers, each of them has been raised to a power, say a to the m, and then that same number a raised to the n, and I want to multiply them. When I want to multiply, I'll either just write things next to each other or I'll put a little dot between them. Never use that times symbol because that looks like an X. Stay away from that. You can just add the powers. So this is a to the m plus n. If I have a similar situation, a to the m, and I'm going to divide by a to the n. So again, the bases are the same, but the powers are different. I can just write that as a to the m minus n. If I have a to the m all raised to another power, like 5 squared all to the third, that's the same as a to the m times n. come over here for a few more. If I want to take a number and raise it to a negative power, this is one that's possible to get wrong in a few different ways. This is the reciprocal of a to the positive version of that power. And then finally, some rules for roots. If I have a fractional power, I'll make this an m, we're using m's pretty much everywhere. A to the 1 over m is the nth root of a. And a to the n over m, you can kind of use this rule together with this rule. This is the same as the nth root of a to the n, which is the same as the nth root of a all to the n. All right, these are some basic algebra rules that will be super useful in simplifying expressions. And you have a handful of kind of very basic homework problems that just ask you to rewrite things using these rules. I'll look at quick little examples here. See what I got for you. Yeah, we should look at that too. Okay, so yeah, sure, what the hell. So let's use some rules to simplify. Something like, yeah, okay. Simplify a to the 1/3 times a to the 7/3. Something like 2a cubed times b to the 4 all to the power of 3/2. And something like 1 over the square root of x times the square root of x. Okay, here we go. I'll back up, give you some time to write. Okay. So for this first guy, I'm going to use that very first rule, right? M here is like 1/3 and n here is like 7/3. And I have a to the m times a to the n. So I'm going to begin by using that first rule that says this is the same as a to the 1/3 plus 7/3. Right, if you multiply like bases, you add the powers. Now 1/3 and 7/3, those are both fractions, and the denominator is the same already. They both have denominator 3. So we just add the numerators. So this is a to the 8/3. And that's it. All right, so you're multiplying like bases, just add the powers. For the next guy, I need to follow a few rules. On the one hand, I have this rule. And on the other hand, I have a rule that says if you take a product and raise those all to the same power, I guess I didn't write this rule out for you explicitly upstairs. tuck one more in here. A times b to the n is the same as a to the n times b to the n. This works with multiplication and division, does not work with addition or subtraction. So if you have a product and you're raising that to a power, you can raise each term of the product to that power on its own. So that, together with this rule, is going to let us simplify this expression. I'll take each term of this product and raise it to the 3/2 power. So I'll have 2 to the 3/2 times, I'm going to use parentheses here, this is a cubed to the 3/2 times b to the 4 to the 3/2. When I was doing my solutions in purple, darn. So use parentheses judiciously. Right, parentheses are your friends. They will help your work be clearer and help you avoid mistakes. 2 to the 3/2, there's not much I can do there. That would be the square root of 2 cubed, or the square root of 8. But we'll just leave him as 2 to the 3/2 because the square root of 8 is not a nice number, it's irrational. Here, a cubed, all raised to the 3/2, that's a to the 3 times 3/2, using this rule. And b to the 4, all to the 3/2, this piece, b to the 4, all to the 3/2, that's b to the 4 times 3/2. Same rule we used on the a piece. And the 2 to the 3/2, this we could write as the square root of 2 cubed, like this, or the square root of 8. Or you could write it as the square root of 2 all cubed. Any of those would be acceptable, but I'll just leave it as 2 to the 3/2 because 8 is not a perfect square. This square root doesn't simplify. So this is 2 to the 3/2 power times a to the 3 times 3 over 2. Well, 3 times 3/2 is 9/2. So this is a to the 9/2. And then b raised to the power 4 times 3 over 2. What is 4 times 3 over 2? What is the power of b here? What is this number? I think I saw an answer from Henry there, but I think you're muted. You can hold space to talk if you'd like.
Is it 6?
It is, yeah. So that's 12/2, right? 4 times 3 is 12, 12/2, which is 6. Or you can think of it like the 4 and the 2 can cancel a little bit. 4 is 2 times 2. So one of those 2's cancels with this, leaving you just 2 times 3, which is 6. All right, and that's it. That's as nice as this is going to get. 9/2 is not an integer. 3/2 is not an integer. I don't know what the number a is, so I don't know if it's a perfect square, so I don't know if I can clean this up. 2 is definitely not a perfect square, neither is 8, so there's no way for us to clean this up. Any questions about what any of the symbols mean here or where we're getting any of the things we get? Don't be shy if there are. Okay, let's go ahead and do this last one and then we'll call it a day. Downstairs here, I'd like to start by just writing that as a statement about exponents. So this is 1 divided by parentheses x times x to the 1/2 all to the 1/2. Right? A square root is the same as the 1/2 power. So the parentheses, those are the big square root because the whole thing x times root x is under that big square root. So I want x times root x all raised to the 1/2. And then the little root x underneath here is just x to the 1/2. And there's more than one way to clean this up. We could approach this downstairs the same way we approached this, where I give this big 1/2 power out here to each of these guys separately, and then try to combine and clean up. But if I'm following my order of operations, I should do all the work within the parentheses first. So let's do that. If I multiply x times x to the 1/2, what do I get and why? What does the inside here simplify to following the rules above? Well, this x is x to the 1, and x to the 1 times x to the 1/2, that's x to the 1 plus 1/2, which is x to the 2/2 plus 1/2, which is x to the 3/2. All right, so I'm doing this common denominator thing here to write 1 as 2/2. So the thing downstairs inside the big parentheses is x to the 3/2. So I have 1 over parentheses x to the 3/2 all to the 1/2 power. Next, I can use, again, this rule to say, okay, x to the 3/2 all to the 1/2, I'll leave it downstairs, but that thing is x to the 3/2 times 1/2. Because I have some number, x, being raised to a power, 3/2, and then that whole thing being raised to another power, 1/2. It is this form. So I can just multiply the powers. 3 over 2 times 1/2 is 3/4. So this is 1 over x to the 3/4. And finally, using the rule up here, I can rewrite this as x to the negative 3/4. So that's job done there. Okay. I will spend a little bit more time on this sort of thing on Wednesday, just a tiny, tiny little bit more time, but then we're going to spend most of Wednesday talking about functions, graphs of functions. I'm going to give you some definitions, look at lots of examples. I want you to get started on the homework today. The first homework set, I am going to leave it up and available to you until next Monday, but I'll be posting another homework set on Wednesday. And normally this first homework set would be due on Wednesday at the start of class, but I want to make sure everybody has time to get in and look at it. But please start on it today. It'll be up in just a few minutes. And the sooner you get working on that, the easier you will find Wednesday's class. One other little note, there are going to be some things in that homework set that I don't go over explicitly in class here because there's so much stuff that I want to kind of check and make sure you remember from your previous math class. If you get stuck on anything there, don't hesitate to reach out. You can use the Discord, you can come by the office hour, whatever you like. But please work hard getting that knocked out, just getting your brains back up to speed and ready to do math again, because I know for some of us it's been a long summer. But that is it from me for today. Do you guys have any questions before I let you go? I think I had someone in chat asking to come back and look at these rules. Sorry about that. Here we go. Here are the rules for exponents. All right, is there anything else I can do for you guys today before we call it quits? Okay, then I'm going to go ahead and end the meeting. I'll have the video up soon. Your homework will be up in the next few minutes. Please get started on that as soon as you can. Remember, I need everybody into WebAssign today. Even if you don't have time to sit down and do the homework today, make sure you get registered for our class in WebAssign one last time. The thing you need to do that is just this class key. Just this. Even if you don't have your access code, you can still register for WebAssign. Please get into WebAssign today. If you don't have your access code, when it gets to that page that asks you for it, scroll down, look for the link that says start trial access. If you do have your access code, go ahead and put it in. The trial access will last for about 2 weeks. After that, you'll get kicked out. Don't let that shit happen. All right, if you're having trouble getting an access code, money problems, whatever, reach out to me. I'll try to help you out. We'll get something going. But please, regardless of whether you have your access code or not, get registered for WebAssign using the class key from the full syllabus. If you didn't download a full syllabus at the start of class, remember that can be found right here in Canvas. Alrighty, that's it from me for today, guys. If you got any questions, come by office hours, shoot me a Canvas message or an email. Otherwise, I'll see you all Wednesday morning, bright and early. Take care.